Hello everyone, my name is Alexey Glukrev, and today's video is quite important and interesting for you, I believe. So, because it's still mobile system design, but we will focus on API design, API contract, and how to collaborate with backend team, how to use different technologies for the backend, and it's basically you need it for any mobile system design interview, because for mobile system design interview you have like three main parts. It's like collect requirements, high level design and diagrams, and usually for almost all the interview you will prepare and show your knowledge about API contracts, and you will prepare and design the API for your mobile application. So why this video is highly important for almost any mobile system design interview. And I believe I will personally use this video in the future when I will prepare for the next company, because in this video a lot of useful information for to recap everything that related to API stuff. So let's see and go on. Okay, let's get started. Mobile system design and design API in this video. Table content for this is just why is this quite important once again. We will talk about communication protocols, use cases, and some requirements for them. We will talk about API structure, some contract-specific things in JSON code and different stuff. We'll talk about tooling and frameworks. We'll compare them and like provide some trade-offs that you will use for your interview, like discussing a lot of stuff, and here's like this is options and you made some decision about it. Versioning and for your API, it's like for your safety. We'll talk once again about why is this so important. Pagination, because it's like common questions for a lot of interviews. Delta updates, also like common stuff that you need to highlight that you know something about it. And then some mocking and contract validation, which is like quite good stuff to mention, and it's useful for your work. Actually, the whole presentation, yeah, it meant to be like some material for interview preparation, but it is useful and important for your actual work, especially if you work for startups or you just starting your career. So it's really good video with a lot of details. And I will also discuss some common mistakes in API design, in choosing some technologies, choosing some different structures in response, and so on and so forth. And we will provide even more. So, couple of like three examples, exactly examples of API. We will discuss it briefly, and it will contain all the knowledge that we gather during this presentation. So let's move on. Why API contract matters? So why this thing is so important? It's basically because, once again, system design and API part, it's like one of the crucial and the frequently asked part. So you always almost for all the interviews, you will talk about API, you will design something. For your mobile application, mostly for all of them, you need some communication with server, some backend work. So almost everything is online right now. So why this thing is so important? And once again, this is also important for your everyday work, for your future in your career, and so on and so forth. Okay, communication protocol. Let's start with this part. So here is like a lot of pros and cons for different protocols. We'll discuss them and what the best for any protocols that we listed out here. And yeah, let's go one by one. So the rest, it's like a general one, like a lot of people knows how to use it, seen it. So it's like for general purpose, it's fit almost everywhere, especially if like a small startup and you don't need to um, complicated infrastructure for that. So it's easier to use REST framework, REST API, so it's easy to implement, but it's verbose and loosely typed. So here's a lot of possibilities to have some mistakes and a lot of things that can be go wrong with this protocol. So GraphQL is another one. So it's quite flexible for UI. For example, if your UI have like different elements, depends on the backend or API response, and you also need to ask your API about a lot of stuff, different stuff, and you don't need to create a new API for that. So yeah, it's a good thing. So it's customized, it's typed. But from the cons, it can be like issue with caching, and it's really complex for debug this stuff. gRPC is basically for high performance stuff. It's a binary protocol, so it's really fast when you need this fastest or a reduced amount of bytes that you transfer over the network. So it's binary, fast, and typed as well. So it's on the other side, it's hard to debug. It has like setup overhead. But on the other hand, gRPC has a lot of generation stuff. So it's when you design contract in one place, it will be easier to use it for almost any languages, especially for mobile. It's like Kotlin, Java, and Swift for iOS. So yeah, it's good things to have the API consistent, but once again, the infrastructure for the backend can be complex. SSE, it's another stuff. It's basically when you need some events from the server. So it's one-way real-time updates. We have like special cases for using SSE compared to the other technologies like WebSocket or push notification. We will discuss it in example sections. So SSE, basically, it's like simple, it's battery friendly. We just receive necessary information from the server side when it's needed. For example, you need some updates in your news feed that someone liked or have a new comment or something like this. So it's no bidirectional, so no bidirectional updates. So you need to send to the server with one way and receive SSE in the back. So it's kind of weird and complex, but it's good for a lot of cases. So WebSockets, it's actually duplex compared to SC. So it's great for chat, for gaming, so it's for real-time stuff. From the cons perspective, it's really complex to connection handling, reconnection logic. It has some proxy issues, so it's also like additional complexity for that. And need to your backend infrastructure to support it. You need your backend engineers nonce have to use it as well. So another stuff for updates is short pooling. Basically, it's quick reactive sync. It's really simple to implement, but on the other hand, it's has high battery consumption, network cost. It's not really efficient. Another stuff, it's long pooling, which is like basically almost the same. Yeah, but it's like it's the same simple infrastructure. It's comparable. Yeah, but it's same time it's wasteful and introduce latency, which is not good. Okay, we discussed protocols. Let's move on. The next one is can be use cases and requirements. So let's define what the screens, what on the screens and what you need for this API. So right now we just thinking what data we need, what we just imagine the screen on that your application and what data you need from the server. It's like one way how to design and have first step towards your API design. So what's data is shown on the screen basically what user action are supported, maybe some buttons, clicks, and so on and so forth. Like think about it, and maybe we need some additional information from the server for those actions. So the next step is determine the data shape. It's like some inheritance, some objects that server will return us, and so on and so forth. Maybe apply some additional UI requirements if you implement some server-driven UI. So it might be something particularly related to UI. It's like colors, maybe some positioning of elements, and so on and so forth. So, and another like sync and load requirements that also like needed for this API, for example, pagination, some dynamic updates, and so on and so forth. We will discuss about this stuff in a moment. So API structure. So first, it's like design consideration. Define is API. It's for server-driven approach or not. Server-driven approach means that server will decide what will be shown on the screen. It's completely fully configurable from the server side. It sends like UI things like colors, element positioning, and so forth. It's not like HTML code, but it's like similar approach. Just send some blocks to your client application, and client will just render it with native components. So should the API define some UI elements or data only? It's once again about that part. So maybe you need just only the data and you have like prepared UI layout and you need just show some piece of data in this layout and that's it. Prefer arrays of objects over the flat maps, like this simple suggestion. It's just easier to iterate, sort, and manipulate data in UI frameworks. Flat maps are harder to validate and visualize. Yeah, simple. We can have some different options to use nested objects. So keep related data together for easier deserialization and display the data. So avoid unnecessary lookups or joins on the client side. On the other hand, we will discuss a bit later this piece of information, but yeah, nested object can be like in different API calls, in different endpoints, or in different objects in the single response. So normalize the shared structure. For example, if you use some user object, for example, for your post or for your message, it's basically not a good idea to include information about the same user every time in the same post or message. It's basically better to use another endpoint to receive all the users in for this block, or maybe some other field in your API, single API that will list all the users that can be use it and it's shown in the post or in the messages. So just avoid duplication. And improve maintainability and backend performance as well. Just if you reduce amount of lines in your API, amount of bytes, so it will be better for your performance. For sure, you can use some JZip or something, some cache algorithms, but yeah, anyway, just reduce amount of data is always better. So API structure means that endpoint strategy. Are we going to use like one endpoint or multiple endpoint? We will discuss for what cases one is better, for what the multiple endpoints are better. So single endpoint means just it's best for the screens that shows multiple types of data at once. For example, just list of messages and nothing can be duplicated. So it allows caching. It's single payload. It's easier to cache actually. If you have just one endpoint, it's easier to cache the result of this. So it's easier for mobile clients to fetch all the data, maybe just serialize it in different ways. So it's single endpoint. It's easy to maintain on the mobile side for sure. So multiple endpoints is different song. So it's better for modelization. So you have like different models on the backend side, different nodes that are responsible for different type of information. For example, one for the users, the other for the list of messages, and so on and so forth. So it's good separation. And so it also can reduce the payload. For example, you ask the list of users at once, receive all your friends, and you know that only friends will text you in the messages, so you don't need this information once again. And it's enable individual updates for parts of the screen, so you can use also different technologies to update it. Yeah, just return back to this individual updates. It means that, for example, you can use different endpoints for different part of the screen. And for example, one is loaded, another one is like showing spinner while we are waiting. So it can be like weird UX experience for the user, but it can be. I personally remember for my couple of previous companies when we use dynamic layouts and server-side configured for them, and some blocks of the screen required another API call to collect more data or show something specific. So yeah, it is a case. So another thing to think about is polymorphism inheritance. For example, the API in its response return you some piece of the data, and while you start serializing it, you see at first the type, and depends on the type, you serialize the data itself. So the API structure can be like different, but it depends on type of each block before you serialize. So we will discuss in an example section why and where it can be useful. So it also requires front-end to branch logic based on the type, as I said. So we need some front-end logic differently, and duplicate basically logic on the iOS and Android if we support both platform to parse this data from the API and render it accordingly. Tooling and frameworks. So once again, it's like I will show you some technology and some example for Android, iOS, and backend. So you can use this for your interview. Just show up with some technologies and frameworks that you need and going to use to implement some of the way interactive API. So REST, it's like simple. For Android, it's Retrofit as usual, OpenTP, and to parse and serialize the data, it's Motion Xon. For iOS, it's Alamofire and Codable. For the backend part, it's FastAPI, Express, Spring Boot. So yeah, GraphQL is basically a Polar. It can have like a different interpretation and implementation for iOS, Android, and server side. gRPC, it's gRPC for Java, Kotlin, and the gateway for the backend. SSE for Android, it's supported by OpenTP and the event source. So event source actually for everywhere. For iOS, it can be URL session, maybe with some custom logic. WebSockets, so OpenTP WebSocket for Android or Scarlet, iOS Starscream or URL session once again. And on the backend, it's like different stuff that can be usable. Short pooling, it's mostly like custom limitation, but for Android, Retrofit supported, so it's like interval-based pooling. For iOS, we need to some custom stuff with URL session once again with timer. And for long pooling for Android, once again, it's Retrofit. It also supports retry logic. In iOS, it's URL session plus repeat calls. Okay, let's move on. So versioning of your API. So why versioning is so important? Because you can, if you apply some changes, you don't want to ruin your previous API, your previous clients, because for different platforms, for example, especially for Android, you will always have like your clients who will use some old version of your application, means that all APIs. So you have to support and maintain this. And if you need to add another new stuff, you don't want to break something like that you implemented before in previous versions. So use URL versions like API version and then name. It's like common tradition. So never rename or remove fields. You can safely add new, but if you just remove or alter some table, some fields, you can ruin the previous version. Only add optional fields. Yeah, it also can be useful for applications that application don't think that you will strictly rely on some contract, and it handle if some information missing. Support accept version header if needed. Yeah, it's also like a useful suggestion. Backward compatibility ensures long-term app stability. As I said before, like you need to support old version if you, especially if your project or company have like a long history of application versions and updates. Pagination is another stuff that frequently asked, and you frequently need to talk about it on your interview. So we have like three base type of paginations. The first one is offset pagination. So it's like get API version name and that offset 20 and limit 10. So just after 20 items, the API should return us 10 more. So it's really simple. It's really simple to implement on both clients and on the service side. But on the other hand, from the cons perspective, so it's inconsistent with real-time data. So it duplicates skipped items when list changes. So for real-time data, it's not really suitable. But for static one, yeah, it's a good solution and a good option. Another way is like almost the same, but instead of offset, you can send as a page and limit of the item on the page, or even just one page parameter, and that's it. So, and it's intuitive for users, so it works well with static data, the same as before, because it's basically the same like offset pagination, but it's same instability as offset for real-time stuff. Uh, for real-time application and real-time updates for infinite scrolls, when you need to change some data, it's better to use cursor-based pagination. So instead of like offset or page number, we send a cursor, basically some ID or hash code that you receive in API. So API will send you just next cursor or next page, maybe some previous page, and you will send these IDs back to the server side to receive next piece of data. So basically, it's the same like cursor query in your database, but on the like in API. Delta updates, another good stuff to have. It's like what does it mean? So you have some API, but at some point you need to update some piece of data, some blocks on your UI, but not all the screens. And basically, you maybe have like quite loaded API and with a lot of parameters, and you don't need to receive all of these. You need to reduce your payload. So you in that case, you will receive only delta updates, just small piece of data that show you what things should be changed in the API. And then you update something in your domain level, in your application, and then update the UI. So in terms of API, like REST or something, HTTP, it's API version name, and we can just ask backend to update in some point, some time, um, yeah, some point of the history. So it reduces the data usage and improves the sync performance, enable near real-time experience without full refresh. So you just update some piece of UI and it can be like invisible for end user, which is also good for a user experience. Requires client to track timestamps or tokens. It means that you need to send to the backend some timestamps to update the data and receive some updates after this time point. It's suitable for inbox style updates, chat history, read receipts, or receive some messages that you have more comments for your thread or something like this. So here is response for the data updates. You can pause this video on any slides that represent the API and see it in details, but basically that's it. So some deltas, operations that relate to this data, it can be add, update, or delete, something like this, and some useful information for each operation. So it's like can be like message if you need to change some message. For example, some user send you some message then edit it. So it will send some delta updates, separation update, and information about message. Yeah, something like this. Okay. Next thing that I want to discuss is common mistakes. Let's go one by one and see how to fix it. So other fetching. It's basically like how it's named. Why it hurts? Because it's a waste of bandwidth and fix use GraphQL or split endpoints and different small pieces. Tight coupling, it means that your client and backend really tight coupled together and depends on information. It's easier to broke something. So to fix it, use like stable and backward compatible schema, also like versions and so on and so forth. Missing pagination. So if you receive something like a big piece, maybe it's good for like your project initial, but if you don't see like in the future and at some point your client will receive like really big responses, so it can produce some crashes or slow loads. To fix it, just for if you predict that you will use some long piece of data, long responses, long list, uh, always use pagination for that. So mixing logic in the client, like it can like what I heard, inconsistent behavior, fix some of this logic to server side. I always tend to say that the client should as simple as possible and only server side should rely on the logic. It can be like for a different perspective. For example, if your company is really trained to send some builds to production app store and Google Play, or just regular way to create a new build and publish into stores, it takes time. So it's always easier to do and fix something on the server side. And yeah, so that's why logic should be on the server side at first. So not versioning, it breaks old versions that we discussed before. Just use your versioning, use different version of API to apply some changes. It's always useful. Using pooling when SSE works. So yeah, it's battery and data inefficiency. So you drain your battery on your device. So you can use real time when it's applicable. So don't use technology because you can use this technology. Okay, and here even more in this Pagination, just get all together and discuss a couple of examples of APIs that also like common questions that people can ask you on the interviews. So the API for that case is messaging app, so messenger chat application, technology stack. It can be like REST for chat history and sync, either WebSocket or SSE for real-time message and delivery. Also, we can use push notification for the backend background notification. So trade-offs for this one, it's like WebSockets give lowest latency and full duplex, but requires a robust connection, and logic. So why we can use SSE for that case, but it depends on different factors for sure. So SSE is easier to manage, but only support one-way delivery. So if you think that you need more bi-directional communication, so WebSocket is still an option. Push notification need if your app in the background for the foreground. Anyway, so push notification is not robust solution and it's better to avoid it. So, but for background work, it's a really good option, especially for iOS. So GraphQL subscription possible, but it adds some infrastructure overhead on the server side. Okay, so here is API for the messaging app. And what we have here, so just avoid duplication, sender info is basically like users. We create some another list of senders, is list of object which is sender, and we connect a message with this object with some ID, sender ID. On the client side, when we will prepare this data for UI, we just parse messages and the senders in the same way at the same time and map them together. Use a separate endpoint, like another option for users or senders. Just have two API calls, but it's not really good suggestion for mobile apps. But yeah, it's still a possible option, especially if you have like a lot of users and you not expect that they will change. So you can call the API for user or senders just once in a while and then just map with this data from your database. This reduce payload for sure and leverage efficient caching. Yeah. So message status like send, delivered, and read is crucial. So we also have it here and basically in none. Attachments, for attachments, it's good practice to use some meta information about attachment types. It can be like file, some images, photo, and so on and so forth. Like also good to have thumbnail URL for like small icon or image and the URL itself. And cursor-based pagination to support infinite scroll into the chat. Yeah, we can see the pagination here to like next page and previous page. Yeah, it's good. We also have like different settings and different features. They can be supported on the client side. It can be like dynamic updates for our case. And yeah, it's also like good option to API will send what features client able to support for this API to have better collaboration and connection between client side and backend side in terms of the different features. Yeah, and it supports dynamic updates as I said, because we have this feature supported. So the next one is a newsfeed API. It can be like in some e-commerce feed, like for Amazon or a home feed. So in terms of technology stack, so GraphQL like ideal for that. So it's customizable, fit layout and subqueries. So it's really good solution for this type of the data. REST with zero aggregated payloads for better CDN caching. Why not? SSE or pulling for updates to feed. Basically, we need to receive some updates from the backend side that on the post or some items or some goods that we previously shopped in the list or feed, we need some updates. Trade-offs and alternatives for here. So multiple images resolution increase the payload size. Just prefer responsive image format like AVIF or CDN Smart Resizing. So basically we have a couple of options. The first option is that API will send you some links on the image's different size, and the client will decide what size is better to show for this particular screen size. And the other option to use some different image format and the CDN for that. So embedding commands in line adds some complexity. Use thread AI. We will discuss on the next slide. We will see some response code. So GraphQL is flexible. REST is more about performance stability at some point. Yeah, but it's a lot of trade-offs here if you compare GraphQL and REST. Personally, if you design something for your interview, you can say that we will use the REST for this version because it's like easier and it's easier to me to explain. Also, like a right suggestion for you, if you don't know some technology, never use it on your interview. Use only those that you really familiar and knows how to work with that. But you can mention that GraphQL can be better for that. Okay, here is a response, some feed items, user object. Right now it's like nested included because we assume that we will receive some feed from a lot of users and they might not be duplicated frequently. But if they might be duplicated, you know what to do from the previous example. So feed is polymorphic. It's using type, so it means that before we parse feed object, it's like an array of objects, and before we parse each object, we see the type of this, and according to type, we map to a particular data. User data is embedded, yeah, as we discussed. Image object include resolution variants. It's not, I believe I just updated. So another option, like right now, use like CDN URL and some information about the format of the file. The next example is push notification. It's like also common stuff, and we need to design this SSE response or push notification, as I said before. So, like best practice here, use minimal payload, avoid network overhead because it's asynchronous response, include human readable message for notification, just simple and for a small limit of cases. Include user object for privacy and the badge icon rendering means that include some information about the user. For example, if you assume that your application can be used by different users and you need to show this push notification only for ones that currently logged in, and to hide the others, you need some information about the user. And also, if your user or someone will write you, you might need some information about the user to show some additional UI data, additional UI information like icon, avatar, or something, name, for example, in this push notification. So timestamp is useful for local deduplication. For example, use timestamp on your payload to order some messages that you receive and see have you already processed this message or not. So technology and trade-offs, push notification for offline background delivery. Yeah, it's like common practice. SSE ideal for foreground and the active sessions. Avoid duplication logic between push and SSE. If you choose one technology, just use it for one use case, not just overlap one with another. So, and consider unifying event dispatcher model with event types. Okay, so here is like small example of API response. For this, we still use JSON, text JSON to be simple and presentable, human readable anyway. So here is like information about the user, some message that we received, and timestamp to check have we already processed this message and maybe shown on the UI somewhere. Okay, thank you. So thank you, and thank you everyone for watching. I hope this video was useful for you. If you have some suggestion about the next video, yeah, just tell me about it. And it was a pleasure to present some new information for you that can be useful for you and for me as well for the future. Thank you, everyone. See ya.